Okay, this is lesson 10.4 in intermediate algebra, and the section is called Equations Quadratic in Form. And what we're going to do is we're going to look at some problems that are quadratic in form. Remember that a quadratic equation looks like this. Okay, not exactly like that, but it always has an x squared, always has an x, and then always has no x at all. So a number times x squared plus or minus a number times x plus or minus a number equals 0. That's a quadratic equation. You've learned three different ways to do this. You've learned to factor it into two binomials. You've learned to complete the square, and you've learned to use the quadratic formula. Any one of these, whoops, that's an A, sorry, got a little crazy in my hoop-de-doo. Okay, any one of these three, two binomials, quadratic formula, or completing the square will work. This one right here probably works the least often and is the easiest. Quadratic formula always works. Completing the square always works. So, when you're given a quadratic equation, you solve for x in one of those three ways. Alright, sometimes things don't look so quadratic formula-ish. We may have something like this. Okay? And you have a couple ways to do that. You can do the FOIL method here and get x squared plus 6x plus 9. Distribute there. Minus 8 equals 0. And combine like terms, this one and this one, and get plus 4x. 9 minus 6 is 3. Minus 8 is negative 5. Okay? And then you can do this, hopefully, where you have a 5 and a 1, and this is a plus, and that is a minus. Okay? And then your x is negative 5 or 1. That's one way of doing it. You just take this whole thing and do the FOIL for this. Distribute this here in here. Don't forget to bring the negative. Add and subtract all like terms, and then factor it down and find your x. Okay, so that is one way of doing this. Alright, golly, let's see if I can get rid of all this. Let's look at another way of doing this. It could be that you just decide, you know, I'm going to try something new and fancy schmancy and see if I like doing this better. And this is just one of your other options. You don't have to do it this way. But we do what is called substitution. And if you plan on going any further in math, you're going to have to learn how to do the substitution. So let's say that instead of an x plus 3 and an x plus 3, we substitute. We say whenever we see a y, we're going to say that's x plus 3. Or whenever we see an x plus 3, we're going to say it's y. So now when we see the x plus 3, we're going to put a y in its place. So we're going to put a y there. Okay, and that squared is on the x plus 3, so now it's on the y. There's an x plus 3 next to the 2, so we're going to put a y there. There's not one over here, and we have that. Well, that looks a lot easier than the first one, and let's see what we can do here. We break it down into two binomials, and we have y, and we have y, and a 4, and a 2, and a negative, and a plus. And my y then equals 4, and it also equals negative 2 for right there. But the question is, were we looking for y up here? No, there's not a stinking y in this whole equation. But what we said is that whenever we see an x plus 3, we're going to put a y in its place. We're going to substitute a y for the x plus 3 so that we can solve this quadratic equation easier here than we could up there. Okay? So what I did is I found out what 4 and negative 2 are. They're going to be my y value, but I wasn't looking for y. I was looking for x. So what I do is I come back up here and I see, oh, whenever I had a y, I put it, or an x plus 3, I put in a y. Let's go back. So now I've got a y, and let's say that that is equal to y equals what? X plus 3. Subtract 3 from both sides, and I get x equal to 1. And I also have a negative 2 here for y, so negative 2 equals x plus 3. Subtract 3 from both sides, and I get x equals negative 5. Those are the two answers I want because that is what was up here, is an x. And that's what I was looking for. So do you see what I did there? I had something pretty complicated. When I looked at the complicated part, the x plus 3, I thought, let's just put in one letter for x plus 3 instead of the x plus 3 being there. So then I put a y there, and I solved for y, and then I put these numbers back in here, and went ahead and solved and found out what my x is. So those are two options there in order to solve these. So let's go ahead and look at some more examples. So example 2 has 4x to the 4th plus 7x squared equals 2. Alright, so let's go ahead and write it so it's equal to 0. Alright, so remember a quadratic formula is a number, x squared, plus a number times x plus a number equals 0. The a, b, and c are just numbers. So a number x squared plus a number x plus a number equals 0. This is the form that I want to get this equation into. Okay, so let's make this a minus 2 equals 0. Okay, so now we've got all of our stuff on one side. Now the problem is we have, whoops, wrong button. We have an x squared and an x. Well, over here we have an x to the 4th and an x squared. So what we're going to do is we're going to say y. In fact, I'm going to go ahead and teach you something. We're not going to use y. In advanced math, they don't use y for these kind of problems. They use the letter u. I don't know why. But they use the letter u. So what I'm going to do is I want this to be a squared, right? So let's say that u equals x squared. Well, let's go ahead and write this as 4x squared squared plus 7x squared minus 2 equals 0. Because this one is really the same as x to the 4th. Okay, now watch what happens. Whenever I see an x squared, I'm going to put a u in its place. Okay? Now I'm going to go ahead and solve it. And I can solve it using the quadratic formula. I can solve it using completing the square. Or I can solve it by factoring it. So let's do quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so negative 7 plus or minus the square root of b squared, 49 minus 4 times a is 4, times c is negative 2, all over 2 times, what is my a? 4. So that is going to give me, and we're going to have to erase some of this later because we're going to have too much writing here. Alright, so square root of 49 plus 4 times 4 is 16, 32 over 8, so negative 7 plus or minus 49 and 32 is going to be 81 over 8. So that's going to be negative 7/8 plus or minus the square root of 81 is 9 over 8. And this is going to be negative 7 plus 9, which is going to be 2 over 8, which is 1/8. So that's, 1/4. So one of my u values is 1/4. Negative 7 minus 9 is negative 16 over 8, which is negative 2. So u equals 1/4 and negative 2. So let's get rid of a bunch of the stuff here. Okay. Alright, so I got rid of all that work there, and this is what we started with, the original. We put a u in for x squared. So whenever we saw an x squared, we put a u, and that was an x squared squared. You know, that's, so we broke it down into that. So u equals x squared. Well, I guess we could actually go ahead and take this one off, because if u equals x squared, then if we square u, we get x to the 4th. So anyway, we get 4u squared plus 7u minus 2. So we've got 4u squared plus 7u minus 2 equals 0. And we found out that u equals 1/4, and it also equals negative 2. So now all we have to do is replace some things in here. So the next step is we know that u equals 1/4, and it also equals negative 2. And it also equals x squared. So we could write, instead of u equals x squared, we could write 1/4 equals x squared, right? Because 1/4 is u, and we said u equals x squared. So 1/4 equals x squared. Take the square root of both sides, and we get 1/2 plus or minus 1/2 equals x. Do the same thing with a negative 2. So we're going to put a negative 2 in for u. Square root, square root. So x equals, remember, if you have a negative in there, you pull an I out, and you can't take the square root of x, or of 2. So that's what you end up with. So this is going to be a plus or minus 2. Whenever you take the square root of both sides like that, you end up with a plus or minus, just like we got here and like we got there. Okay? I know these are kind of complicated, aren't they? Well, let's do one more. See if I can describe it in a way that it maybe doesn't seem so terrible. And you know, these just come with practice. It just takes a while, and I'll just do this on the next video.